In this video, we will learn about arcs and arc lengths. First, what is an arc? Let's look at this circle. If we cut a part of the circumference of this circle, what we get is an arc. This remaining part is also an arc. If we cut this part further, we get more arcs. So all these parts of the circle are arcs. This shows that arcs are parts of the circumference of a circle. Now let's draw the circle with center O. Mark 2 points on the circle as P and Q. Which do you think is arc PQ? Is it this green arc? Or this red arc? Actually, both arcs are arcs PQ. Notice that the green arc PQ is shorter than the red arc PQ. We call the shorter green arc as the minor arc PQ and the longer red arc as the major arc PQ. To differentiate the two arcs, we can mark points R and S on the circle. Thus, we can call the minor arc PRQ and the major arc PSQ. Now let's learn about the distance along the circumference between these 2 points P and Q. We call this the arc length PQ. Now how can we find this arc length PQ? First, draw 2 radii from O to the points P and Q. Look at this angle at the center of the circle here, formed by these 2 radii and the arc PQ. We call this angle the angle subtended by the arc PQ at center O of the circle. Now observe what happens when the point Q moves along the circumference of the circle. Can you see that when the length of arc PQ increases, the subtended angle at O also increases? Let's watch again. How can we use this relationship to find the length of an arc? Let's look at 3 examples. In this first example, the minor arc PQ is 1/4 of the circle. That is, the length of the minor arc PQ is 1/4 of the circumference of the circle. The angle subtended by PQ at the center O is 90 degrees. In this second example, the arc PQ is a semicircle, or half of the circle. That is, the length of arc PQ is half of the circumference of the circle. The subtended angle is 180 degrees. In this third example, the length of arc PQ is the same as the circumference of the whole circle. The subtended angle is 360 degrees. Now, did you notice any pattern? Let's study them again. In example 1, we can see that when the arc PQ is 1/4 of the circle, the subtended angle is 90 degrees. The ratio of 90 degrees to 360 degrees is also 1/4. In example 2, the arc PQ is half of the circle, and the subtended angle is 180 degrees. The ratio of 180 degrees to 360 degrees is also half. In example 3, we can see that when PQ is the whole circumference of the circle, the angle at the center of the circle is 360 degrees. We can conclude that the arc length PQ is always a fraction of the circumference of the circle. This fraction is the same as the ratio of the subtended angle to 360 degrees. We can thus multiply this fraction by the circumference of the circle to find the arc length. Therefore, if the circle has a circumference of 20 centimeters and the subtended angle is 90 degrees, then minor arc PQ is 1/4 of 20 centimeters. That is 5 centimeters. When the subtended angle is 180 degrees, the arc PQ is half of 20 centimeters, which is 10 centimeters. Let's look at the relationship between the arc length and the subtended angle again. The length of an arc is a fraction of the circumference of the circle, and this fraction is equal to ratio of subtended angle to 360 degrees. Therefore, if we have an arc PQ subtended by an angle theta on a circle with radius r, the arc length PQ can be found using this formula. Now let's use this formula to calculate arc length. If we have a circle of circumference 60 centimeters and the angle subtended by minor arc MN in this circle is 60 degrees, what is the length of arc MN? First, we find the ratio of the subtended angle to 360 degrees. The subtended angle 60 degrees divided by 360 degrees gives us 1/6. Since the circumference of the circle is 60 centimeters, the arc length MN is 1/6 multiplied by 60, which gives us 10 centimeters. Now let's find the length of major arc CD in this last example. The radius of the circle is 35 centimeters, and the angle subtended by major arc CD is 216 degrees. We know that to find arc length, we need the angle subtended by the arc and the circumference of the circle. However, in this example, we are given only the angle subtended by the arc CD, but not the circumference of the circle. Can we still find the arc length? We know that the radius of the circle is 35 centimeters. Given the value of the radius of the circle, we can find its circumference. Circumference of the circle is equal to 2 pi times radius, which is 2 pi times 35 centimeters. This gives us 70 pi centimeters. We also know that the angle subtended by the major arc CD is 216 degrees. So the ratio of the subtended angle 216 degrees to 360 degrees is 3/5. The length of major arc CD is 3/5 times the circumference of the circle. Taking pi to be 22/7, the arc length is 132 centimeters.